Somewhere in the darkness between the stars, far from any sun, a planet the size of Jupiter is moving through the galaxy entirely alone, and there may be more of these wandering worlds than there are stars in the Milky Way. Somewhere between the stars, a planet the size of Jupiter is drifting through total darkness, with no sun to orbit and no light to cast a shadow on its clouds. It has been moving this way for longer than the Earth has existed. It passes through nothing, disturbs nothing, and carries no name. The nearest star is years and years of travel away, even at the speed of light, and the planet does not move at the speed of light. It moves the way cold things move in the dark, steadily, without urgency, without arrival in mind. The galaxy turns slowly around it, the way everything turns slowly around everything else, when the distances are large enough that motion becomes almost philosophical. The space between stars is not empty in the way a room is empty when the furniture is gone. It is empty in a more thorough way, a way that is difficult to hold in the mind all at once. If the sun were the size of a grapefruit and held in one hand, the nearest star would be another grapefruit sitting somewhere in Asia, and the space between the two would contain almost nothing. A few drifting atoms of hydrogen here and there, the occasional particle carried outward on ancient solar wind, and darkness so complete that darkness feels like too small a word for it. The scale of this emptiness is the kind of thing the mind reaches toward, and then gently retreats from. And yet, the emptiness is not perfectly empty. And this is the thing that tends to go unnoticed for a long time. There is a strong human habit, perhaps an old and useful one, of dividing the universe into places and the spaces between places. Stars are places, planets are places. The gaps between them are simply the getting there, the traveling, the pause between one thing and the next. But the universe does not organize itself around human habits, and the space between stars turns out to be a place of its own, with its own quiet population, its own slow traffic, its own hidden objects that move through the dark without announcing themselves. Some of those objects are small, chunks of ice and rock flung outward from distant solar systems long ago, following long curved paths through interstellar space that will eventually bring them close to some other star, or will not, depending on small gravitational nudges accumulated over millions of years. Some of them are larger, worlds, full planetary bodies, carrying their own geology and their own internal heat, and whatever frozen atmosphere they have managed to hold onto across the long, cold crossing. These larger wanderers are the ones that are most difficult to see, most difficult to count, and most difficult to imagine. A planet without a star is a dark object in a dark place. It emits no light of its own that any telescope built so far could detect at interstellar distances. It reflects no sunlight because there is no sunlight to reflect. It is, from almost any observational standpoint, invisible. A presence inferred more than seen, a category of object whose existence became accepted before any individual member of that category could be pointed to and named with certainty. The logic came before the sightings, the way the logic of many things in astronomy tends to arrive first, worked out in equations and probability, and then confirmed slowly, imperfectly over decades of watching and waiting. The watching and waiting continues tonight, as it does every night, in observatories at the tops of mountains and in the slow drift of space-based instruments, turning their attention to dense fields of distant stars, looking for the particular kind of faint brightening in a star's light that means something massive and dark has passed in front of it. The technique is patient work. It requires looking at many thousands of stars over many nights and finding, within all that steady light, the brief and subtle change that signals an unseen traveler. But even with all that watching, the number of rogue planets detected remains far smaller than the number that almost certainly exist. The calculations that describe how solar systems form, the long gravitational negotiations between young planets jostling for stable orbits, suggest that for every planet that settles comfortably into a path around its star, others are lost, flung outward, set adrift. sent into the dark with no particular destination and no timetable. How many of these wanderers are out there crossing the space between the stars at this moment is a number that defies easy expression. Estimates tend to run into the billions, and those are estimates only for this one galaxy, which is itself one of what current estimates suggest could be trillions of galaxies stretching away in every direction. The scale of the wandering population is, in other words, the kind of number that functions more as a feeling than a figure. A sense of vast and patient motion occurring everywhere at once, in every dark place, in every direction, without pause and without witness. The planet drifting between the stars right now, the one that opens this story, is not unique. It is not even unusual. It is simply one of an enormous number of worlds moving through the dark in the same quiet way. Unhurried, untethered, carrying whatever they carry across a distance that has no edges anyone has measured. The story of how such a world comes to move through the dark alone begins long before any darkness settles in a place full of noise and motion and collision, a place nothing like the stillness that follows. Every star is born from a cloud of gas and dust, a slow collapse that takes tens of millions of years and produces at its center a new sun, hot and young, surrounded by the leftover material of its own formation. A flat, spinning disk of debris that circles it the way a shallow whirlpool circles a drain. Within that disk, material gathers into clumps. The clumps sweep up more material. Over time, over enormous stretches of time, they become worlds. Not in a single event, not all at once, but incrementally, grain pressed against grain, rock adding itself to rock, until something large enough to hold itself together under its own weight begins to travel a more or less stable path around the young star at the center. This process sounds orderly, and in the very long view it becomes orderly, but in the middle of it, it is not orderly at all. The early period of any solar system is a crowded and turbulent place. There are far more objects than will ultimately survive. Smaller bodies crash into one another and either merge into something larger or shatter apart. Large worlds migrate inward and outward as they interact with the disk of material surrounding them, drifting through zones they would not occupy in the system's later, quieter life. The orbits of neighboring bodies pull on one another constantly, nudging trajectories in ways that accumulate over thousands of orbits into something significant, like the way a very small tilt in the angle of a long table will eventually cause a marble to roll to one edge and fall off. The large planets are the great movers in this story. A planet with the mass of Jupiter carries with it a gravitational influence that extends across an enormous region of space. And when a smaller body passes through the zone where that influence is strongest, the encounter does not always end with the smaller body simply returning to its original path. Sometimes it leaves with a different orbit entirely, stretched out into something longer and more elliptical, carrying it farther from the star than it has ever been before. This happens again and again. The stretched orbit brings the smaller body back through the inner system, and the large planet is there again, and the orbit stretches a little more. Each encounter is a transaction of energy, a small portion of the large planet's motion transferred to the smaller world, and over hundreds or thousands or millions of such encounters, the sum of all those small transactions becomes very large. The smaller world moves a little faster than it otherwise would. Its orbit grows longer. Its farthest point from the star reaches farther and farther out, until one pass through the inner system sends it outward on a path from which it simply does not return. There is no single dramatic moment when this happens. The world does not know it is leaving. It travels the same trajectory it has always traveled, following the same physics that has always governed it, and the difference between the orbit that brings something back and the orbit that carries it away is, in the moment of departure, very small. It is only with the passage of time that the distinction becomes absolute. What follows is not abrupt. For a very long while, after a world is flung loose from a young solar system, it may remain in the general neighborhood. The outer reaches of the system where the star's light is already very dim, where the sun appears as little more than a bright point among other bright points. The world continues moving. The sun grows fainter behind it, not all at once, but incrementally, the way a sound fades over distance, until there is no longer any meaningful sense in which the world belongs to that system at all. The star, for its part, barely registers the loss. A solar system sheds worlds the way a tree sheds seeds, not as an act of grief or disruption, but as a natural consequence of the forces already at work. The remaining planets adjust slightly to the new gravitational balance and continue their orbits. The sun burns on. The system settles into the quieter arrangement it will maintain for billions of years, with no record of what left and no visible gap where the departed world once traveled. The ejected world, meanwhile, carries with it everything it had accumulated in the time it spent forming. It may have a solid surface, still warm in its interior from the energy released during that process of accumulation, energy that comes from all the collisions and compressions that built it up from smaller pieces. It may have an atmosphere collected from the gases that surrounded it in the disk. It may have ice. It carries all of this out into the space between stars, where the temperature drops toward the lowest values that exist in nature and where nothing else is close enough to exert any meaningful pull. The journey, once fully underway, is simply motion. Constant, unhurried, undisturbed motion through a medium that offers no resistance and contains almost nothing. The galaxy rotates around the world as the world drifts through it, the stars moving in their own slow paths across the background, none of them close enough to be anything more than light. The world does not accelerate. It does not slow down. It moves at whatever speed the last gravitational interaction gave it, and it will continue at that speed for an interval of time so long that the word interval loses much of its meaning. This is the general shape of one kind of departure, the kind born of company and chaos, the kind that requires a busy system and a large neighbor and enough time for small nudges to add up to something irreversible. It accounts for a very large portion of the worlds now drifting through the galaxy alone, the ones that began somewhere warm and crowded and ended up here, in the long quiet, carrying the geological record of an early life that included a star and then did not. The geological record is patient in a way that almost nothing else is. Deep inside a world of this kind, the layers of rock and ice and compressed material hold the shape of everything that happened during formation. The pressures, the temperatures, the order in which things settled out as the world cooled. None of that is lost simply because the world moved. A world's history does not require a witness to remain true, and the slow accumulation of stone does not need a sun nearby to hold its form. Whatever was built in the chaos of that early system persists, carried forward into the dark, perfectly preserved in the way that very cold places preserve things, essentially unchanged across distances no instrument has yet had cause to measure. And then there is the other kind. Not every world that wanders was flung. Not every rogue planet carries within it the memory of a star it once circled, the faint geological echo of a solar system it was expelled from. Some of these worlds have no such story to carry. They formed alone, in the open dark between stars, without any sun to orbit, and without any system to leave. They have been wandering since the very first moments of their existence, because wandering is the only state they have ever known. The process that makes them is not so different, in its broad outlines, from the process that makes stars. Across the galaxy, there are vast regions where gas and dust accumulate over enormous stretches of time, drifting together in slow currents shaped by gravity and the subtle pressures of the space around them. In most places, when enough material gathers and the pull of gravity becomes strong enough to draw everything inward, the result is a star. a dense, hot object at the center of a collapsing cloud, eventually igniting and burning for billions of years. But the galaxy is not tidy. The collapse does not always produce something large enough to burn. Sometimes the cloud is too small, or the conditions are slightly off, and what forms at the center is something dimmer and quieter, something that almost crosses a threshold and then does not. A world formed this way comes into being at the center of its own small cloud of collapsing material, drawing inward from the surrounding gas and dust in the same broad strokes that a star does, but arriving at a very different destination. Where a star ignites, this object simply settles. It grows warm from the compression itself, the same process that heats any gas when it is squeezed, but it never reaches the internal temperatures needed for the kind of sustained nuclear burning that defines a star. It becomes dense, and then denser still, until the inward pressure is balanced by the resistance of the material itself, and then it stops. It cools over long timescales, very gradually releasing the heat it accumulated during formation, and it drifts. These objects exist along a spectrum that resists easy categorization. On one end are things that are clearly planets, worlds of rock or ice or dense gas, cold and dark, incapable of producing their own light. On the other end are things that are clearly stars, hot enough and massive enough to sustain their own burning for billions of years. Between those two ends, however, there is a region that belongs to neither category fully. Objects massive enough to trigger some nuclear reactions in their cores, but not massive enough to sustain them. Objects that glow very faintly in infrared light, a kind of radiated warmth invisible to the naked eye, for a time before cooling into darkness. These are sometimes called brown dwarfs, which is simply a name for a failed star, or perhaps a very large planet, depending on where one chooses to draw the line. The boundary between a brown dwarf and a very massive planet is genuinely difficult to locate. Astronomers have spent considerable effort trying to agree on where one category ends and the other begins. And the honest answer is that the universe does not observe such distinctions. It simply produces objects across a continuous range of sizes, and human categories are imperfect tools laid over a reality that has no interest in being sorted. A world formed alone from a collapsing cloud, and a world flung from a distant solar system may, once they have both cooled into darkness, look nearly identical to any instrument that finds them. The histories that produce them are entirely different. The objects themselves are almost indistinguishable. What matters, in a quieter sense, is not the category but the aloneness. A world that formed in open space, without a star, without companion planets, without the context of a solar system around it. That world has a particular kind of solitude built into its very origin. It did not lose anything. There was never a warmer time, never a phase when sunlight crossed its surface and changed with the hours. From the first moments of its coherence as an object, there was only the dark and the slow outward drift, and the stars arranged at their vast distances in every direction. It is a stillness that predates any possibility of motion in a sense. The wandering is not something that happened to these worlds. It is simply what they are. Their formation and their isolation are not separate events separated by some catastrophe. They are the same event, continuous and unbroken. The collapsing cloud, the coalescence, the cooling, the drift. One long, quiet process that never had another chapter available to it. And yet these worlds are not nothing. They are substantial objects, dense with compressed material, carrying within their interiors whatever chemistry the original cloud contained. The gas and dust between stars is not pure emptiness. It holds carbon and oxygen and hydrogen and trace quantities of heavier elements forged in the deaths of earlier stars and scattered outward. A world that forms from this material inherits it. The composition of the interstellar medium becomes, over time, the composition of the world. What was once diffuse and formless becomes solid and specific, a particular arrangement of matter in a particular place, defined by the exact conditions of its collapse. There is something almost meditative about this origin, viewed across enough distance. The galaxy is full of slowly moving gas, and some small fraction of that gas finds conditions sufficient to collapse inward on itself, and some small fraction of those collapses produce not a burning star, but a quiet world. And that quiet world then spends the remainder of cosmic time drifting through the very medium it was born from. The material never fully separates itself from the wider substance of the galaxy. It simply becomes denser in one location for a while, organized into a sphere by its own gravity, and then continues to move through the broader dark, as it always would have, as all the material around it also moves, slowly and without urgency. The numbers involved, in terms of how many such worlds might exist, resist easy compression into anything manageable. The galaxy contains hundreds of billions of stars, and current understanding suggests that freely drifting worlds, whether flung from solar systems or formed alone in open space, may be at least as numerous, possibly far more so. The category may be the most common kind of world in the galaxy, and yet it is essentially invisible to ordinary observation, because worlds that produce no light in orbit, no star, leave almost nothing for a telescope to find. They announce themselves only by accident, by passing briefly in front of a more distant star and bending that star's light in ways that betray the presence of something massive and dark along the way. But that detection story belongs to a later part of this account. What sits here, in the consideration of these worlds born already wandering, is simply the image of formation without belonging, a small cloud finding its center. Material falling inward through its own gravity over thousands of years. The slow organization of chaos into something dense and roughly spherical. A world arriving at its own existence in the middle of nowhere, without a system around it, without the gravity of a nearby star to shape its early path. Just a world, suddenly coherent, surrounded in every direction by the open space of the galaxy, which has no opinion about its presence, and will accommodate its long journey through the dark with the same patience it extends to everything else that moves within it. The surface, if it could be stood upon, would offer a sky unlike any other place in the known arrangement of worlds. There would be no sun, not a dimmed or distant one, not one reduced to a particularly bright point among the others, but no sun at all. The sky in every direction would be the same sky, the ancient permanent star field, the same one visible from anywhere in the outer galaxy, spread in its full uninterrupted sweep from horizon to horizon and directly overhead. No single point of light would be brighter than the rest by any meaningful degree. No direction would be oriented toward warmth. The stars would simply be there, in their thousands and their millions, depending on how far the eye could resolve them. Each one a cold point of ancient light, and together they would illuminate almost nothing. Standing in that light, if standing is the right word for whatever form of presence the imagination allows in such a place, the ground itself would barely be visible. The starlight arriving from all those distant suns is enough, in aggregate, to give a faint sense of surface, a slight, directionless illumination, the same quality in all directions, casting no shadows because it casts nothing with enough conviction to produce one. Rock or ice or whatever the ground is made of would exist at the very edge of visibility, just barely there, more suggested than seen. The cold would be something else entirely. On the worlds that orbit stars, cold is relative. Even the outermost, most distant planets still feel the faint mathematical presence of their sun's warmth, however little of it arrives after the long crossing of space. But here there is no sun to be distant from. The temperature on such a surface, absent any internal heat of the planet itself, would settle toward the ambient temperature of the surrounding space, which is only barely above the lowest temperature that is physically possible. Cold enough that familiar chemical processes slow towards stillness. Cold enough that most gases familiar from temperate worlds have long since frozen solid, and lie underfoot as minerals. The atmosphere, if one remains at all, would be pressed thin and heavy by that cold. It would not stir. There would be no wind in the conventional sense, no pressure differential between warm air rising somewhere and cool air rushing in to replace it, because there is no source of warmth to initiate that ancient circulation. The stillness that results is total. It is a different kind of stillness than the stillness of a winter night in a quiet place. That stillness is borrowed. It exists against the background of a world that is turning, a sun that will rise, air that is capable of movement and will move again. The stillness on such a surface is structural. It belongs to the place the way the rock belongs to the place. There is no morning coming. There is no season turning. The star field overhead will look essentially identical in 100 years and in 1,000, because the planet is moving through the galaxy but moving through space, so vast that the constellations visible from it will shift only on timescales longer than anything a human mind can hold as a felt duration. The sky simply is what it is, and will remain so. And yet there is a certain coherence to it. The stars that are visible from that surface are real stars, with real systems, real planets in real orbits, some of them almost certainly with liquid water somewhere on their surfaces and something moving through it. The galaxy that fills the sky is the same galaxy, the same structure of several 100 billion suns, slowly rotating over hundreds of millions of years, its arms curving through distances that swallow the imagination whole. It is the same place. This wandering world is not outside of things. It is inside the same large structure as everything else, obeying the same gravitational arithmetic, participating in the same slow turning. Whatever ground exists underfoot would have accumulated the marks of its long journey. Dust from the interstellar medium, the faint material that fills the space between stars, would have settled over geological time into the surface, leaving trace elements from distant nebulae, from the remnants of stars that exploded before this solar system's sun ever ignited. The rock itself would carry the record of its formation in its mineral structure, and that record would be largely unaltered, because there is no geological renewal here, no volcanic resurfacing, no plate tectonics fed by the heat of a nearby sun. What formed would persist. The face of such a world could be among the oldest unmodified surfaces in the galaxy, a record of conditions from billions of years ago, left perfectly undisturbed in the cold. The sky above all of it would continue its patient, barely perceptible rotation as the planet moved through the galaxy. Stars so far away that their proper motion would take centuries to trace into lines across a long exposure image. The permanent star field, unmarked by any sun's rising, entirely without the rhythm of day, turning with a slowness that is less like movement and more like the quality of deep time itself, made visible in the motion of light. Down near the surface, in whatever thin and frozen atmosphere remains, ice crystals of various compounds might drift in quantities too small to see and too cold to feel, settling over millions of years into the faint layering of material that covers the ground. Nothing would be loud. Nothing would shift on any timescale shorter than geological. The only sounds, if there were any, would be the slow internal sounds of a body of rock, responding over enormously long periods to its own gravity and its own cooling. Deep interior adjustments, measured in epochs, occurring far below the silent surface. The star field above continues. The cold holds. The ground, ancient and unmarked by anything but time, extends in all directions to a horizon that curves gently away, unremarkable and vast, with the same quiet permanence in every direction, under a sky that has looked essentially the same for billions of years and will continue to do so for billions more, patient and complete and utterly without urgency, the way all things at this scale eventually come to seem, when they are considered long enough and from a sufficient distance. And yet, somewhere beneath that surface, something persists. Not warmth in any ordinary sense, not the warmth of a fire or a sun or even of breath in a cold room, but warmth in the deep geological sense, the slow bleeding of heat outward from a core that has been cooling since the world first condensed from its cloud of dust and gas. Every rocky world carries this inheritance. The process by which certain heavy elements, uranium, thorium, potassium in its rarer form, break apart slowly over immense spans of time, releases heat as a natural consequence, steady and patient and continuous, a kind of ticking that never winds down within any time frame that would register as significant to anything alive. This is not a combustion, not a burning, but something quieter and more fundamental, a process that has been underway since the elements themselves were forged inside dying stars long before the solar system existed, and it continues now, unwitnessed, deep inside worlds that drift through the dark with no sun to warm them from outside. On a world with a star, this interior heat is overwhelmed. The sun dominates everything, and the contribution of the planet's own interior to its surface temperature is negligible, a footnote to a much larger story. But remove the star, let the world travel alone through interstellar space for billions of years, and the interior heat becomes the only heat, the last and only argument against absolute cold. Whether it is enough depends on many things. The size of the world matters. A larger planet holds more heat simply by virtue of having more interior volume relative to the surface through which that heat escapes. A small rocky world, something the size of the Moon, loses its internal warmth relatively quickly, cooling to a state of near total geological silence within a few billion years. A larger world, something several times the mass of the Earth, holds its heat far longer, pressing it slowly outward through thick layers of rock that conduct heat reluctantly, giving the interior time to remain warm, or warm enough, across timescales that are difficult to hold in mind. The atmosphere matters as well, and here the story becomes unexpectedly interesting. A thick atmosphere, the kind that might accumulate around a world with significant internal geological activity, volcanic gases slowly released over billions of years, hydrogen and other light components held close by sufficient gravity, can act as a kind of blanket, not in the way that a sun warms a world through its atmosphere, but in the simpler way that insulation works, by slowing the rate at which heat escapes. Even in the absence of any star, even with no incoming energy from outside, an atmosphere has the capacity to reduce how quickly a planet loses its interior warmth to the void of space. The world beneath remains, in relative terms, less cold than it would be without that covering. Not warm by any standard that would seem comfortable, not warm in the way that matters to living things at the surface, but warm in the specific and narrow sense that matters for what might exist below. Beneath the surface, deeper still, there is the question of water. Water is not rare in the galaxy. It forms readily, a simple combination of the two most abundant reactive elements, and it appears throughout the universe in the form of ice, locked into the bodies of comets, asteroids, and planets alike. A world that formed with enough water in its composition would carry that water inward, and under the right conditions, under the insulating weight of rock above, warmed from below by the slow decay of heavy elements, that water might remain liquid. Not at the surface, which is exposed to the cold of interstellar space and frozen to temperatures at which most familiar processes halt entirely, but in a layer somewhere between the frozen exterior and the warm interior, in the way that an ocean can persist beneath a thick layer of ice if something below is generating enough heat to prevent it from freezing completely. This is not entirely theoretical. Within the solar system, several moons orbit far from the sun, receiving almost no solar energy, and yet liquid oceans exist beneath their icy surfaces, kept liquid by heat generated through the gravitational interaction with their host planet, which squeezes and flexes their interiors as they orbit. A rogue planet has no planet squeezing it, but it has its own interior, its own inheritance of slowly decaying elements, and for a world of sufficient size and composition, that inheritance alone might be enough. The ocean, if it exists, would be dark. Completely, uniformly dark, without even the dim, filtered light that reaches the deepest ocean trenches on Earth. The pressure at depth would be immense, the product of kilometers of rock pressing inward from above. The water might be saline, charged with minerals dissolved from the rock it has been in contact with for billions of years, mineral-laden in the way of very old water that has had time to dissolve everything the stone around it has to offer. It would be still, likely in the way that deep enclosed water tends towards stillness, with any circulation driven not by tides or wind or solar heating, but by the slow convection of warmer water rising from below and cooler water settling from above, a gentle and persistent turning, patient as everything else at this scale. Whether anything could live in such a place is a question that the science does not settle, and perhaps does not need to. The point is something quieter than that. The recognition that warmth persists in unexpected places, that the universe does not require a star to maintain the conditions under which familiar chemistry remains possible. The conditions for liquid water are more widely achievable than they might appear from the vantage point of a planet bathed in continuous sunlight, and the galaxy is full of objects traveling through the dark that have never been close enough to a star for starlight to matter. There is something in this that resists easy articulation. A world, dark and cold at its surface, ancient and unmapped, traveling alone through interstellar space with no destination and no sun to orbit, carrying within it a quiet interior warmth, a buried ocean turning slowly in permanent darkness, heavy with minerals and patient beyond any reckoning. There is something in that image that settles rather than disturbs, that suggests not emptiness, but a kind of self-contained completeness. The world does not need anything from outside. It carries what it has carried since the beginning, burning through its inheritance at a pace so slow that billions of years register as barely a beginning, insulated from the void by its own atmosphere and its own depth, continuing the way that deep things tend to continue, without drama, without urgency, without any particular awareness of the vast and starless space through which it drifts, unhurried and whole. And yet, for all that wholeness, for all that self-contained silence, these worlds do occasionally make themselves known, not by any signal they send outward, not by any light they produce, but by the faint and momentary way they reach into the fabric of space itself and bend what passes through it. The method is old in concept and patient in practice. Light traveling from a distant star follows the most direct path available to it, but space is not a rigid grid. Wherever mass exists, space curves gently around it, and light curves with it, the way a river bends around a stone without breaking, without pausing, without any disruption that the river itself would recognize. When a rogue planet drifts between a distant star and the instruments of an observatory on Earth, the gravity of that invisible world bends the star's light around itself from multiple angles simultaneously, gathering those rays together the way a lens gathers light, briefly concentrating the star's glow into something brighter than it was a moment before. The star has not changed, the planet has not announced itself, and yet the brightness rises, holds for a time measured in hours or days, and then fades back to its ordinary level as the planet continues on its way into the dark. This brightening is called gravitational lensing, and its subtler planet-scale version is sometimes called a microlensing event, the prefix acknowledging that the effect is small, brief, and easy to miss. What makes rogue planets particularly distinctive within these events is the brevity. A star passing in front of another star produces a brightening that might persist for weeks or even months, the overlap long and leisurely. A planet has so much less mass and so much less gravitational reach that its effect on passing light lasts only a day or two, sometimes only hours, sometimes less. The signal is like a breath held and released, there before the observer has fully registered it, gone before the instruments have gathered enough data to be certain of what they saw. Only by watching enormous numbers of stars simultaneously, night after night, and by catching these momentary brightenings in the act, can astronomers be confident that something real and dark has passed between here and there. The challenge has always been one of patience and scale. Any single patch of sky holds thousands of stars, and any single night those stars hold still in their familiar places, burning at their ordinary brightness, offering nothing that looks like the passage of an invisible world. The rogue planets are out there, distributed through the galaxy in numbers that current estimates suggest are staggering. Perhaps more of them than there are stars, perhaps several times more, the galaxy carrying more untethered worlds than anchored ones, though the full accounting remains beyond what any instrument has yet achieved. The gap between that possible abundance and what has actually been confirmed is simply a gap in observation, a consequence of how faint the signal is and how briefly it shines. What has been confirmed is already enough to settle the question of whether these worlds exist at all. Events consistent with planet-sized objects drifting free of any star have been recorded, light curves rising and falling on their characteristic short timescales, the fingerprint unmistakable once the eye learns to recognize it. Each confirmed event represents a single world crossing a single line of sight at a single moment, the intersection of its billion-year journey with the geometry of an observatory and a distant star, a coincidence so improbable in any individual case that the fact of its happening again and again speaks to the sheer number of these worlds moving through the galaxy at any given time. Instruments now being prepared for operation will change the scale of this search in ways that are difficult to fully hold in mind. A space-based telescope named the Nancy Grace Roman Space Telescope, now fully built and awaiting a planned launch on a Falcon Heavy rocket in late August 2026, is designed to watch millions of stars simultaneously with a field of view far wider than previous instruments, catching micro-lensing events in numbers that will transform a handful of detections into a census. Astronomers expect it to find not dozens but potentially thousands of these brief brightenings, attributable to free-floating worlds, building for the first time something that approaches a true count, a population map of the wanderers distributed through this corner of the galaxy. What that census will likely reveal is not entirely unknown, even before it is taken. The models of how solar systems form and how young planetary systems shed their excess members suggest that smaller rocky worlds are ejected more readily and more often than large ones, simply because the physics of flinging a world loose from a system's grip scales with mass in particular ways. Lighter objects require less energy to push beyond the point of return. And so the galaxy's rogue population is expected to lean toward the smaller end, full of worlds in the rough size range of Earth or somewhat below, rocky and cold and numerous beyond easy comprehension. Whether the census will confirm this, whether it will produce surprises at the large end or the small end, or in some other dimension entirely, remains genuinely open. There is something unhurried in the act of counting this way, something almost philosophical in the method. The planets do not cooperate. They do not emit anything detectable, do not reflect enough light from distant stars to register in any direct image, do not announce their existence by any ordinary means. They are known only by their gravity, which is the most fundamental thing any object possesses, the one property that cannot be switched off or diminished, the way mass reaches out into space around itself simply by existing. To detect a world this way is to catch it doing nothing more than being what it is, massive, present, crossing a line, and to read its existence backward from a pattern in starlight that lasts less time than it takes to fall asleep. The accumulation of these events, each one brief and individual, each one the record of a single passage across a single line of sight, somewhere in the vast middle distance between Earth and the galactic center, adds up slowly into something that begins to feel like understanding. Not complete understanding. The distances are too great, the planets themselves too dark and too numerous for any inventory to claim finality, but understanding of a gentle, statistical kind, the kind that settles over a subject, the way sediment settles over the floor of a deep and quiet lake, building up layer by layer until the shape of things below becomes legible from above. It is a patient science, suited to patient subjects. The rogue planets themselves move without urgency, drifting through the interstellar space between stars at speeds that are significant by ordinary measures, but negligible against the distances involved, taking millions of years to cross from one part of the galaxy to another, their individual paths curving slowly under the influence of the galaxy's own rotation, the whole vast structure turning around a common center, while the wanderers trace their long arcs through the dark. That the instruments built by a species on one small anchored world should be sensitive enough to catch these moments of crossing, should be capable of noticing the brief and gentle brightening that says something invisible just passed. There is a quietness in that capability, a kind of listening that asks nothing from its subject and disturbs nothing in return, only watches and waits and records what the light says as it arrives. And the light continues arriving, as it always has, crossing distances so large that any single human life would fit inside them without being noticed, carrying information that the wandering worlds themselves will never know has been gathered. The rogue planets drift on, indifferent in the way that only very old and very large things can be indifferent, their surfaces unchanged by the moment of detection, their interiors still pressing warmth outward through kilometers of rock, their atmospheres, where they have them, still moving in slow circulation patterns that have been turning since long before anything on Earth had eyes to open. There is something in the sheer duration of these journeys that resists ordinary comprehension, not because the numbers are too large to be spoken, but because the kind of time involved is simply not the kind of time that living things were built to feel. A rogue planet that was flung loose from its star 4 billion years ago has been traveling, without interruption, for longer than the Earth has existed. It moved through the dark while the solar system was still settling, while the first oceans were forming, while single-celled organisms were beginning their long, patient work of transforming everything. It was already old when the first fish appeared. It was ancient, by any ordinary measure, when the first forests grew, and still it drifted and drifted and drifts now, and will continue. The galaxy around these wanderers is not still, though it can seem so from any single vantage point. The whole structure turns, arms of stars sweeping slowly around a dense and luminous center, each star carrying its own retinue of worlds and moons and smaller things, the entire arrangement in motion across timescales that make even the rogue planet's long journeys seem brief by comparison. The wanderers move through this turning structure, the way a leaf moves through water, carried partly by the current and partly by whatever original velocity sent it on its way, tracing paths that are curved by the same forces that curve everything else, belonging to the galaxy even without belonging to any particular part of it. Some of these worlds have been traveling so long that the stars nearest to them have changed entirely since the journey began. Stars live and die on timescales that are long by any human measure but short compared to the full age of the universe, and a rogue planet old enough has drifted past neighborhoods that no longer look the way they did when the planet first arrived. The stars it passed in its early wandering are gone, or changed, or have become other things, and new stars have formed in regions of gas and dust that were empty when the planet's journey started. The wanderer notices none of this. It simply continues. The cold that settles on these surfaces is the cold of genuine isolation, not the cold of a winter night or a high altitude, or even the frozen reaches of the outer solar system, but the cold of being entirely alone in the dark, with no star close enough to matter, with warmth coming only from within and dissipating slowly into the surrounding void. This cold has a permanence to it that ordinary cold does not. It does not wait for a season to change or for the sun to rise. It is simply the condition, stable across millions of years, the background state against which everything else on such a world must be measured. And yet something about these worlds, turning slowly through the dark, carrying their internal warmth, completing their vast, unhurried orbits around a galactic center they will never approach, suggests not desolation but a kind of completeness. They are not waiting for anything. They are not moving toward a destination. The journey and the being are the same thing, each moment of travel indistinguishable from every other moment in the long, unbroken passage through the quiet between stars. The galaxy holds, by the most careful estimates, more of these wandering worlds than there are stars to count, possibly far more. A population so large and so dark that it will take generations of instruments to even begin to understand its true extent. Each of those worlds is somewhere right now, crossing some unmapped region of space, its surface cold and its core warm, and its path curving gently under forces it cannot feel. Each one has been exactly where it is for this moment, and will be somewhere slightly different in the next, the motion continuous and unhurried, the dark around it unchanged. There is a rest in imagining it. Not the rest of things stopping, but the rest of things continuing so steadily, so smoothly, over such an immensity of time that the continuation itself becomes a kind of stillness. The rogue planets drift. The galaxy turns. The light from distant stars travels outward and is eventually gathered by instruments and recorded and studied, and the wandering worlds move on, unaware and unaffected, carrying their long silence with them through the dark. The dark, it turns out, is full of this. Full of things moving too slowly to seem like motion, in spaces too large to seem like places, over stretches of time too long to hold in the mind all at once. The wanderers are out there now, have always been out there, will be out there long after the species that first detected their shadows has become something else or nothing at all. They do not require observation to continue. They do not require understanding to persist. They simply move, and the galaxy moves around them, and the long drift goes on.